Hey guys, welcome back. In this video, we are going to prove that derivative of sin x equals to cosine x, and we will do it by using the first principle. Okay. Now, I have already stated in the video that from the first principle, the derivative of any function is that if y is the function of x, then we have that derivative of y with respect to x is change in y with respect to change in x when limit change in x tends to 0, which is f x plus h minus f of x upon h limit when h tends to 0. And here the delta x and this h is same, it just shows the small change in x, which is delta x. Okay, and we also write as h, and we have the function as y equals to f of x, which is sine of x, and we are going to prove using this first principle by putting this formula. Okay, now we have that derivative of y with respect to x is equals to derivative of sine x, right, with respect to x is limit when h tends to 0 sine of x plus h minus sine of x divided by h. Okay, and we will expand this expression using the addition of the angle formula. We know that sine of a plus b is sine of a cosine of b plus cosine of a sine of b. By using this, we are going to expand this expression, and we will get limit h tends to 0 sine of x cosine of h plus cosine of x sine of h minus sine of x whole divided by h. Now in this expression, we can find that this sine and this sine is common. We can collect sine x as common. By doing that, we will get h approaches to 0 sine x cosine h minus 1, right, divided by h plus cosine of x sine of h upon h. Okay, now as I have already proved in the earlier video, the important result of the two limits, which is cosine x minus 1 divided by x when x approaches to 0 will be 0, and limit when x approaches to 0 sine of x upon x equals to 1. So by using this, we will evaluate this limit. Okay, and if you see this, we can distribute this limit to both of the term, and by distributing it, we will get limit h tends to 0 sine of x cosine of h minus 1 divided by h, right, plus limit h tends to 0 cosine x sine h upon h. Okay, and if you observe this very carefully, there are terms like sine x and cosine x which is independent of this h, so it will be not affected by the limit, and when h tends to 0, it will remain as cosine x and sine x only. So by isolating those terms which are not affected by the limit when h tends to 0, we will get sine x limit h tends to 0 cosine of h minus 1 upon h plus cosine of x limit h approaches to 0, sine of h upon h. Now what we observe is that this expression and this expression is exactly what we have already proved in the earlier videos as well as I have written here. So what is the limit when cosine x minus 1 divided by x? When x tends to 0, it is 0, which means this is actually 0 and this is actually 1. So we will have that this whole expression will be 0 and this whole expression will be cosine x times 1. Therefore, we have successfully proved that derivative of sine x with respect to x is cosine x, okay, from the first principle, which will also imply that integral of cosine x dx will be sine x plus c. And this is very important result and the fundamental result in the derivatives which involve the trig functions. And this is the proof from the first principle. I hope you have understood and enjoyed the proof. Thank you.